Transformations with nonlinear functions. Exercises. Determine the value of x that minimizes or maximizes each of the given expressions. Alright, so x minus 4 squared is smallest in value when x equals 4. When x equals 4, 4 minus 4 is 0, and that is the smallest value that this can be. Here, 4 times the absolute value of x plus 7 is minimized when x equals negative 7. When this is negative 7, this cancels out to 0, and this whole thing is 0, so the answer is negative 7. Here, negative 2 times x minus 5 squared is the largest in value when x equals, well, 0. So x would equal 5, therefore this part would be equal to 0, and that's going to be the largest that it can possibly be. So the answer is 5. And here we have negative 3 times x minus 6 is maximized when x equals, alright, so if we put 6 in here, this will be 0, which is the largest amount that it can be, so the answer is 6. The minimum value of the function f of x equals x minus h squared plus k is f of h equals k. The maximum value of the function g of x equals negative x minus h squared plus k is g of h equals k. Exercises. Determine the value of x and the values as described. F of x equals x minus 2 squared plus 5 is smallest in value when x equals 2. When x equals 2, you plug 2 in and you'll get 5, which is the k value. So you see f of h equals k. Alright, moving on. This one is minimized when x equals negative 5. When you plug negative 5 in here, you end up getting negative 7 as a result. So g of h, which is our h value here, equals k, which is negative 7. Here, this negative 2 times x minus 3 squared plus 1 is largest in value when x equals 3. When x equals 3, you plug 3 in and you will get 1 as a result. And this is a downward facing parabola because a is negative. So that's why it's largest in value at the vertex. Alright, and finally, f of x equals 3 minus 2 times x minus 6 squared is maximized when x equals 6. When you plug 6 in here, this entire term goes away, and we're left with 3 as a result. The minimum value of the function f of x equals x minus h squared plus k is f of h equals k. The maximum value of the function g of x equals negative x minus h squared plus k is g of h equals k. Determine the value of x and the values as described. If f of x equals the absolute value of x minus 2 plus 5, this is smallest in value when x equals 2. When x equals 2, this equals 0, and f of 2 equals 5. G of x equals the absolute value of x plus 5 minus 7 is minimized when x equals negative 5. G of negative 5 equals, well, this whole thing drops out, and we're left with negative 7. H of x equals negative 2 times the absolute value of x minus 3 plus 1 is largest in value when x equals positive 3. When x equals positive 3, we have h of 3 equal 2. So this whole part here becomes 0, and we're left with 1. And finally, f of x equals 3 minus 2 times the absolute value of x minus 6 is maximized when x equals 6. When x equals 6, this whole term drops out, and we're left with 3. So f of 6 equals 3.